when we have a double or a half angle, and that's like a 2x or a 1/2 x, we're going to use these new identities. So you got them right there on your purple sheet. I'm going to derive one of them for you just to show you they're not just made up. They actually came from somewhere. If we had the sine of 2x, we could think of that as the sine of x plus x. Would you agree with me? And now it's a sum. So we have a formula. What's the formula for the sine? Sine of the first, cosine of the second, plus cosine of the first, sine of the second. What do you notice about those two terms? They're the same. So we can write them together as 2 sine, cosine. And that's your double angle sine identity, right? That's on the purple sheet. So all of these formulas can be derived in that way. We're not going to derive anymore. We're just going to use them off the sheet. So let's see how these problems work. I'll pick one like I'm assigning tonight. Simplify that. The directions say simplify that. Okay, so we'll start with that. Okay, so what are your thoughts? What's sine 2 theta? We just did that one. What's sine 2 theta? 2 sine theta cosine theta. Now cosine 2 theta, this is an interesting one. This is a really interesting one. What do you notice on your purple sheet about cosine 2 theta? There's like 3 different versions of it. And the reason that there are 3 different versions of it, this is the main one for the cosine of 2 theta. But what do we know about cosine squared? Think about some of your other identities. What do we know about cosine squared? It can be rewritten, can it? How can it be rewritten?
Sine squared.
Be careful.
Minus 1.
Be careful. 1 minus sine squared. Now listen, kids. That's too important. You can't risk confusing that. So keep in mind, sine squared plus cosine squared is 1. So always, 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 if you keep that in mind, you can rearrange. And if you rearrange that, you can see that cosine squared is 1 minus sine squared. So that's how we get the one of the other versions. There's another version of cosine 2 theta. So here's like the main one. But sometimes we want to use this one. And there's yet another one, isn't there? How do you think we get that other one, that third one on the purple sheet there? Any ideas? Go back to the main one here. What's sine squared? What does sine squared equal? No, what does sine squared equal?
Sine squared equals cosine minus 1.
Be careful.
1
minus cosine squared. So if we step 1 minus cosine squared in here, do you see how you would get that third identity, which is 2 cosine squared minus 1? So when you do these problems, you have to decide which one you're going to use. In this problem, I didn't read you the directions, I should have. The directions say, write the expression as one involving only sine theta and cosine theta. So it really doesn't matter which version you use. I'll just use the main one. And I'm done. I'm done with the directions asked me to do. And I know what you're thinking. You're thinking, Mrs. Ford, I thought you said simplify. That doesn't look very simplified. Well, the directions said simplify using only sine theta and cosine theta. Look at my variables. Do I have only sine theta and cosine theta? Yeah, so I've met the criteria. Let's try a better problem. That really wasn't a very good choice. Let me see if I can pick a better one. let's try to solve this equation. Okay. Let's try to solve this equation. And we're going to do it in radians, just for fun.
Just forgive me.
Oops, forgot to turn my phone off. Here we go. Here is the situation. This equation is not solvable in its current format because it has a 2x and a plane x. That can't happen. You can solve an equation with all 2x's, and you can solve an equation with all plane x's, but you can't do both. So who has a thought about this? Can we do anything with this? Look at your purple sheet.
Yeah.
You don't have to have these memorized at this point. Look at your purple sheet. Can you do
Cosine.
anything with that?
Cosine squared x minus sine squared x.
Okay, that would be one option, right? One option would be to replace this with cosine squared minus sine squared. That's absolutely okay. Is there any other option? Sometimes there isn't. Is there another option in this case?
Yes.
What else could I do?
1 minus 2 sine squared.
Oh, now Harry, why might that be a better choice in this particular problem?
Oh, I mean, because there's like signs.
Because there's already a sign in the problem.
It's a sign.
Exactly. So if we didn't have this, then it wouldn't make any difference at all. But since there's this random sign already in the problem, and we have a choice, we're going to pick this version of the cosine 2x. If this had been a cosine, then I would have picked the other version, 2 cosine squared minus 1. Now, take a look at what we've got. What do you think we might do next? Well, what kind of equation is that? Think big picture now. What kind of equation is that?
Say quadratic.
It's a quadratic. And my quadratic equations I like to have set equal to 0. Because then I'm going to do what with it? I'm either going to factor it, complete the square, or use the quadratic formula, right? That's what I do with quadratic equations. So let me get this thing in the right order. Okay? And I don't know, I can't deal with this. I don't know why this bothers me so much, but I don't like having my leading coefficient negative. So I'm personally going to have to divide that out. You don't have to do this. Only people with my issues need to do that. I have an issue. So I'm just going to divide everything by -1. Now I can factor it. How is that going to factor? Now take your time and look at it. Don't be scared. It's easy. How's that going to factor? I'm going to have a 2 sine x here and a sine x here, right? Don't I have to have a 1 and a 1 there? Now I just have to figure out my SIGNs. Think about foiling. Where do you want the plus and where do you want the minus? First one's plus, second one's minus. Now what? It's a big problem. We're not even halfway done yet. put them both equal to 0. So we have 2 sine plus 1 equals 0, and sine minus 1 equals 0. All right? Now what? Solve them. So this one says sine equals negative 1/2, and this one says sine equals 1. Now what? No, we gotta engage our brains now. You gotta think about this for a minute. Where will the sine be a negative number? Start with that. Where will the sine be negative?
Quadrant.
Quadrant 3 or 4. Pay attention to the directions. We're going all the way around the circle, so we have the whole window of opportunity here. Quadrant 3 and 4. How do we know the sine is negative in 3 and 4?
Because of the negative. I think it's on the bottom.
Because
Y.
sine is y, right? Sine is y. Now the sine is negative 1/2. Does that look at all familiar to you?
Yeah.
This would be root 3 and this would be 30. Shoot, I'm in radians though. So let's not say 30. What is 30 in radians? Pi over 6. How do we know that? Well, we know 30 is a sixth of 180. So it's pi over 6. Both these are. Is pi over 6 our answer?
No.
Nope. This is your answer. What is that?
That is 4 over 6, which is 2/3.
This is pi plus a sixth. So how am I going to write that?
7.
7 pi over 6. Very, very good. It's 1 pi and a sixth. The other answer is this one. What's he?
It is 2 pi minus 1/6 pi.
Yep.
Equals
John Preston, get your head up.
11/6 pi.
11/6 pi. Very good.
Yeah, high five.
I cannot imagine anyone finding this boring. This is very exciting stuff.
I'm
Now,
excited.
what about the second one? All right, so we got our answers here. What about this one? Okay. What about the number 1? That's kind of a special number. Zeros and ones are special. I want the sign to be 1. I gotta think about my circle here, folks. Where is the sign 1? 90 degrees, but we're in radians, so we'll say pi over 2. There are the answers to the question. Wow. The only new part of that was right here, making that substitution, taking out cosine 2x and replacing it with 1 minus sine squared, 2 sine squared. Everything else is skills we have already supposed to have accumulated. All right, let's try one more of those. And we'll do a little work on our practice test. Okay, we'll do this one in degrees. And I am open for suggestions. You're walking down the hall, you find this problem, you have to solve it or they're gonna put you in detention hall. So what are you going to do to start?
Take the detention hall. That's all I'm gonna have. So it's already in signs.
It's already all in signs.
That's good news, but there's still, it's all in signs, and that part's positive, but what's negative about it? What's not good?
The 3.
Yeah, you can't have part of your problem with an X and part of your problem with a 3X. You can't have that. Diana, you can't have that. So, what are we gonna do? I don't see any 3X's on my purple sheet, do you?
No.
Shoot.
Uh-oh.
Can't you just
Divide.
take
Take out. You find a way to take one of those side effects and add it to the other. No, you could take out, just take out
One
sign
of the side guys.
Okay, now wait a minute.
divide it?
Some of you are saying factor out something. No, nothing here factors.
Divide everything
Okay,
by sign.
nothing here factors, but that has to be dealt with, Andrew.
Can you just like the sums
Yep.
to make it so it's like sine x plus 2x or?
Yep, that's exactly what you want to do. So we are going to take this guy right here and write him as the sine of 2x plus x. In other words, we got to break that 3 down. This you know how to handle. You may not have it memorized yet, but you need to get it memorized. But you have your sheet. What do I do when I have the sign of a sum? Sine of the first, cosine of the second. This is the first, this is the second. Plus cosine of the first, sine of the second. Now, it's certainly getting worse before it gets better. This is yicky. Right? But, tell me about that right there. What's that? So let's take that out and replace it with what's on the purple sheet, 2 sine cosine. And then we still have that cosine there. So this, I'll underline the parts that match. This is this. Plus. Now what are you going to do with this?
1 minus 2 sine.
Now, earlier somebody was excited because the problem was all sines. So if we want to try to keep that, we would replace this with 1 minus 2 sine squared. You will not go wrong, kids, if you replace it with any of the 3. Any of the cosine 2x replacements will be fine. Some of them will just require some extra steps. I don't know. I think this is the best one to use, but I really won't know until I get a little further into the problem. We have sine x plus 2 sine cosine squared plus sine x minus 2 sine cubed. All right, now don't be confused. This term has a cosine times a cosine, so I put them together as cosine squared. This is a distribute, so I took sine x times 1 and sine x times negative 2 sine squared. You should know what to do next. This is a problem, right? What can we do with that? If this equals
Minus 1.
yeah.
1 minus.
What do I do with cosine squared?
1
Replace it with 1 minus sine squared. I don't know if we were all up late buying cereal last night or what, but we're a little bit out of it today. We need to get with it. These are hard problems. Hey Peyton, am I gonna have to call your mother?
I hope not.
Where are you on your iPad?
For not math reasons.
So I was afraid of.
I was afraid of that. This is what just come to her.
Your mom's such a nice lady.
She is a nice lady, but that's not a reason you should call her.
She's a very nice lady.
So I did the replacement. Does everybody understand why I need to take out the cosine squared and replace it with 1 minus sine squared? Okay, so what have I got? Now I'm going to fix this up. I'm going to distribute. This is ugly. Okay, so all I did was recopy, but I distributed here. So I took 2 sine times 1 and 2 sine times negative sine squared. Collecting like terms. I have how many sines in that problem? Sine, 2 sines, 4 sine x minus 4 sine cubed. Now we're making progress. This was getting quite scary, but now it looks good. What can we do now? Take out a 4 sine. And what will that leave me with if I take out a 4 sine? 1 minus sine squared. Very good. What do I do next?
4 sine x equals 0.
4 sine x equals 0? Or 1 minus sine squared equals 0? So this says sine equals 0, which is a special number. And this says sine equals plus or minus 1, which is another special number. Still with us? Am I going to draw any triangles this time? No, because look, I have zeros and I have ones. Those are somewhere on the circle here. Okay, this time we're answering in degrees because of the directions. Where is the sign 0? Here and here. So we'll say x is 0 and 180. Very good. Here, whoever shared that. That's awesome. Now, where is the sign positive 1? They've got a plus or minus here. Let's do the positive 1. Where is the sign positive 1? 90? And where is the sign negative 1? 27. When you start these problems, unfortunately, you never know how many answers you're going to get. It's not like regular algebra, where you know if it's a cubed, you're going to get 3 answers. You just don't know with these. Sometimes you get 1, sometimes you get none, sometimes you get 4. You just don't know. Okay? All right, today I want to just focus on the double angles. On Monday, we'll do the halves. After we take our quiz. So let's practice a little bit for our quiz. No, the double and half angle identities aren't on the quiz. The quiz is over the first 3 sections of the chapter. This is the 4th section, so it's not on there. The first 3 sections. So the kinds of questions you're going to have to be able to do, we practiced some of them yesterday. We have to be able to find, let's say, the sine of 255 and the cosine of negative 165. All right, let's start with this. Let's work through these two kinds first. Actually, they're the same kind of problem, just two examples of it. Okay, you need to be able to do this on Monday all by yourself. So what's our strategy?
Find the answer.
Yes, that's our goal, is to find the answer. How are we going to do that?
Get it to two angles that are 60 or 30 years.
Maria, what are you doing?
Sorry.
Because Tony and I have been emailing. Yeah.
Tony is her bio.
Okay, Maggie says 210 plus 45. Plus 45. Right? Now, what's the formula say? Now, by Monday, you have to have it memorized. No purple sheets on Monday.
What?
So, oh no. Sine of the
We
first,
gotta have the quiz on Tuesday.
cosine of the second, plus cosine of the first, sine of the second. Now, did we need to use 210 and 45? No, there are other options. That's a good option, though. So what happens now? Now we find these values. Now, the cosine and sine of 45 are the same number, because opposite and adjacent are the same in a 45, 45, 90. Do you remember what those are? Root 2 over 2. So if you have that memorized, you don't have to draw the triangle. You only draw the triangle to help you get the numbers. If you know what the numbers are, you don't need the triangle. Personally, I need to draw 210 because I don't have 210 memorized. So there's 210. What's my reference angle? 30. So this is 1, 2, root 3. Anything negative in there? I have to pay attention to that.
Yeah, both.
Both of these are negative. We're in quadrant 3. So what's my sign?
Sine is -1/2.
Sine would be -1/2. And cosine would be negative root 3 over 2. Now we're going to multiply these. What's my denominator going to be? 4. And my numerator will be negative root 2 minus root 6. Okay. Now, how about this one? Cosine -165. Same kind of problem. I'm just giving you two examples. Cosine -165. What do you want to do with that one? First of all, if you're bugged by the negative, you don't need to be, but in this case, we can just erase it. We can ignore the negative. How come I can do that? Because it's a cosine. Remember your even odd identities? What's the cosine of a negative number equal?
A regular
Just cosine. There are two functions that act this way, cosine and secant. All the rest of them, if this had been a sine problem, you couldn't erase the negative. If this had been a sine problem, what do you have to do with the negative?
You have to
You
reverse
have
it.
to move it out in front. So one option in this problem, since it's a cosine, just ignore the negative. Another option is to leave it in there and just add or subtract to get a -165. Either way is fine.
Is it possible to like instead find like the cosine of like 195, which is just like not in the negative form?
She says, could I, instead of doing 165, Could I find the cosine of 195? Would that be the same thing? Why would she pick 195?
Because 195 plus 165 equals 360.
If you draw negative 165, it looks like this, right?
80 plus 15.
That's the same position as positive 195? Absolutely, that would be another strategy.
Can you do that for all functions?
Uh-huh, yep. You could find the whatever function of any coterminal angle, it'll be the same thing, yeah. Okay, so I don't care, we gotta finish the problem. So you wanna use 165 or 195? 165, doesn't matter. They're both gonna give you the same answer. This part will look different, but the answer will be the same. If we stick with the 165, how are you gonna rewrite it? 120 plus 45. If you went with 195, what might you do? 150 plus 45? Anytime they end in 5, I like to use 45 as one of my angles. You don't have to. Cosine 120, what's the formula? Cosine 120, cosine 45, minus sine 120, sine 45. Again, groupies, you are responsible for these sum and difference identities on Monday. Okay, what do we do now? Plug them in. How about for the 45s? Cosine and sine of 45 is root 2 over 2. I'm going to draw my 120 because I don't have that one memorized. You might, and it's okay if you do. It's great if you do. What's the reference angle for 120? 60. So this is root 3, 1, 2. Anything negative in there? The 1's negative, okay. So what's the cosine of 120? Negative 1/2. What's the sine of 120? Root 3 over 2. Oh my goodness gracious. What is this answer going to turn out to be? Negative root 2 minus root 6. Do you think that happens? Do we get the same answer sometimes? Yeah, a lot. Because we're using the very same numbers. Maren?
Will there ever be a question that's like, given sine of 255, find like cosine or like the angle where the cosine is the same answer?
Oh, I see what you're saying. Yeah, actually that would be easy because sine and cosine are co-functions. So they'll always, so now, I say that's easy. If it's an acute angle, it's really easy. The sine of 60 is the same as the cosine of 30. The co-functions have the same value at the complements. So if you have the sine of 10, that will be exactly the same as the cosine of 80. Now, if the angle is not acute, if it's a bigger angle, like 165, then you have to look at the reference angle, but you also have to pay attention to the positive or negative. So for example, the cosine of 165 is negative, okay? Its reference angle, if you draw 165, which I never do because I can't deal with 165, but its reference angle would be 15. So it's going to equal a sine problem of any angle whose reference angle is 75. 15 and 75 make 90. But you have to watch the SIGNs because this is negative, so you're going to have to make sure whatever you put here would also end up being negative. Okay? So I am not going to ask you that question. You could do it. You can figure it out. Okay, that's question 1 on the quiz, or will be a question on the quiz. I don't know if it'll be question 1 or not, but it'll be a question. Another question on the quiz will be simplified.
So this is multiple 3. Correct?
Board's that way. Spin around.
same stuff. What's that one?
Okay. Here are some examples of another question that's going to be on your quiz. Again, you just got to know the identities. If you don't have them memorized yet, look at your purple sheet. The first problem here says sine, cosine, minus cosine, sine. What's that a formula for? Sine, cosine, minus, that's a sine formula. Now, is it a sine of a plus or a minus?
A minus.
Minus. What's being minused?
18 minus 12.
18 minus 12. So the answer is the sine of 6. Next. Somebody said it's obviously a tangent formula. It is obviously a tangent formula. Is it the plus or the minus? Minus. What's being minused? 114. So this is the tangent of 86. Cosine, cosine, plus sine, sine.
Cosine.
It's a cosine formula.
Negative.
Negative. 18 minus 15, so this is the cosine of 3. This one got tricky. Be careful.
It's a negative cosine.
It's a negative cosine. Why is it a negative cosine?
Because there's a negative. All right, so if you switch it around, like
It's
just
backwards.
it's going
It's
to have a
backwards.
negative up top.
This is not an identity. You don't have anything on your purple sheet that says sine, sine, minus cosine, cosine. It's backwards. So you're going to have to take out a -1, and then you can write it as cosine, cosine, minus sine, sine. Mrs. Ford, are you going to get tricky like that? Yes. This is backwards. You can turn it around if you factor out a negative. Now, what's this? That's the cosine of the cosine of 28 plus 13. So the answer is negative cosine 41. Another one I might get tricky on is this. Now what's going on with that?
I have a question.
It's upside down. Now wait a minute. It's a tangent upside down.
It's a cotangent.
It's a cotangent. So this would be a cotangent. Okay, now it's a tangent upside down. So this would have been the numerator, right? So it's going to be 15 minus 11. So this is the cotangent of 4. Stephen?
I just have a question on the cosine one where you put a negative. I understand that, but didn't you say that like you can't have a negative cosine?
Oh, no. Well, you can always have a negative. No, this negative's in a different spot, Stephen. What that identity says is if you had the cosine of negative 41.
Then it's not a negative
Yeah,
cosine.
this negative, this means the opposite of. This problem is backwards, so we have
Okay.
the opposite.
So you can't have a negative cosine that says that you always it's a positive.
Yeah, this is taking the cosine of a negative number. This is an actual negative cosine.
Okay, that makes sense.
Okay.
Problems where you only do like one side.
Yep, that's next. That's right here. You're gonna have to verify something. And I found a whole bunch more good ones. I don't know if we've done any of these or not. I got these out of a different book, so we'll see. So here's a verification. Now, there are lots of different ways, as always, that you can start this. But a couple of things I want you to keep in the forefront are, when I look at this fraction right here, just this fraction, I have a cosine squared over a 1 plus sine. That can be reduced pretty easily if you choose to do that. Because what do you know about cosine squared?
Is a 1 minus a sine.
So if you rethought that as 1 minus sine squared, then what could you do with it?
You can simplify.
Okay, now multiply by the conjugate. What about 1 minus sine squared? We spent a whole day talking about that, or half a day. What's 1 minus sine squared? It's the difference of
It's the difference of size.
squares.
It is right. You're right.
So what's going to happen if you
Cancel.
factor that as the difference of squares? Those are going to cancel, right?
Yeah.
And you're left with sine plus 1 minus sine,
And negative sine
which
plus
is just
sine equals
1, which is what you wanted. Now, you don't have to do the problem that way, but I do want you to keep that kind of stuff in mind. Cosine squared is the same as 1 minus sine squared, and 1 minus sine squared will always factor. What else might you have done in this problem? Could you have gotten a common denominator?
Yeah.
Yeah, that's probably your best next option, would be to get a common denominator and add the two fractions together. All right, let me throw one more up here. We can at least talk about how to get it started. Now, remember on Monday for this problem, this kind of problem, you have to do something. So when you look at this, what occurs to you as something you might do? Change the cotangent and tangent into sines and cosine. Now then they're going to both be fractions. Sine over cosine, cosine over sine. So what might you do once you get those fractions? Find a common denominator, right? And then, I don't know what you're going to end up with, but at that point then you may have to change some things around. Notice you got a 1 minus 2 cosine squared, so you might end up over here with like a sine squared in your problem, which you would rewrite as what? What's sine squared? 1 minus cosine squared. And I bet you can do that in about 3 or 4 steps. Okay? Homework for tonight is in section 5.4, but the quiz is only over sections 5.1 to 5.3. 2 days in a row we've practiced quiz type problems.
How do you write the answers?
The answer would just be, assuming that you started over there, this side didn't stay the same all the way down. So you're just going to have, this has never changed. You can write it each time. I don't. I just this side is going to do all this work, and it's going to end up being.
So you like, and the answer is like equal.
It won't be an answer box. I'll be grading each of those steps, like a proof. Oh, it's Friday! Whoa, 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 it's Friday!
What's this called?
That sucks. This
It's all.
Because you're the first seat, aren't you? You're the first seat, like in the back. Yeah. Yeah, I'm on like, in the corner, where you were on the whiteboard. Not by the door, but the other one. Thanks, Katie.